Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the proof of Theorem 10.3 and 10.4 of Chapter 10 Circles NCERT Class 9th. So let us start with the Theorem 10.3. The Theorem 10.3 states that the perpendicular from the center of a circle to the chord bisects the chord. Okay, so it is saying that if we draw a perpendicular from the center of the circle to the chord, let us say this is a circle and the AB is the chord over here. AB is the chord over here and circle is having a center O. So the perpendicular is drawn from the center to the chord. It is bisecting the chord. So we have to prove that AM is equal to MB. AM is equal to MB. Okay, so we have to prove AM is equal to MB. Okay, so when we will prove this, we will be proving our Theorem 10.3. Okay, so let us take the triangles, triangles AMO and OMB. Okay, so two triangles are there, AMO and OMB. Okay, so OM is the common side. OM is equal to OM because it is common for both the triangles. Okay, and OA is equal to OB. Okay, and OA is equal to OB because it is the radius of the circles. Only one circle is there. It is the radius. OA is a part of this triangle and OB is the part of this triangle. So both the sides of the triangle are equal because they are the radius of the circle. Okay, and it is being given to us that the perpendicular is drawn to us. So angle OMA is equal to OMB is equal to 90 degrees. Because it is being given to us perpendicular, so the angle formed here is 90 degrees. So we have got three criteria to be fulfilled for the congruency and they are fulfilled over here. So my triangle AMO is congruent to triangle OMB by RHS. Right angle, hypotenuse side. Right angle is there, hypotenuse is there, and common side is there. Okay, so both the triangles are congruent by RHS. So we can easily say now AM is equal to MB by CPCT. Corresponding parts of congruent triangle are always to be equal. So AM is equal to MB, and this proves my Theorem 10.3 because 10.3 Theorem says that the perpendicular drawn from the center of the circle to the chord bisects the chord. So it is bisecting the chord in two parts, two equal parts. So here the theorem is proved, hence proved. Okay, so now let us move on to the theorem number 10.4. Theorem 10.4 says the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So it is bisecting the chord, but we don't know that it is perpendicular or not, and this thing we have to prove. Actually, the Theorem 10.4 is just the converse of Theorem 10.3. It is just the reverse of Theorem 10.3. We can say it is a converse of Theorem 10.3. Here it is being given to us that AM is equal to MB. It is bisecting. The line drawn is bisecting the chord, but it is not given that it is perpendicular to the chord. So this thing we have to prove it. We have to prove it that the line drawn from the circle to the chord is perpendicular. Okay, so we will be starting our proof by taking the triangles. Taking triangles AMO and BMO. Okay, we have been taking the triangles. So it has been given to us AM is equal to MB. It has already been given to us. Okay, and OA is equal to OB because it is the radius of the circle. Radius is always equal. Also, OM is equal to OM because it is common for both the triangles. Okay, it is common for both the triangles. So we can easily say triangle AMO is congruent to triangle BMO by SSS criteria, side criteria. Now when the triangles are congruent, we can easily say that this angle is equal to this angle. Right now we can only say that this angle, that the angle OMBA is equal to angle OMB, but we do not know whether they are making 90 degrees angle or not. That we will be proving later. So let us say angle OMA is equal to angle OMB by CPCT. Corresponding parts of congruent triangles are always equal. Now when the angles are equal, they are making here the linear pair. So when they are making a linear pair, both the angles sum should be equal to 180 degree. So angle OMA plus angle OMB will be equal to 180 degrees. And since angle OMA is equal to OMB, so I can replace angle OMA with OMB. Okay, so angle OM, here we can write the reason, linear pair. Pair sum is 180. Okay, so I can replace here OMA with OMB. So OMB plus angle OMB is equal to 180 degree. Or I can write twice of angle OMB is equal to 180 degrees. And angle OMB is equal to 180 upon 2, which is equal to 90 degrees. Okay. So this is proved now. My angle OMB is 90 degrees. Okay. From here. And when my angle OMB is 90 degrees, we have already proved above that OMB is equal to OMA. So I can easily say it is equal to OMA also. So this angle is also 90 degrees. Now when angle comes out to be 90 degrees, that means it is sure that the chord is perpendicular. The bisecting chord is perpendicular to this chord. The line drawn from OM, the line OM is bisecting the chord and it is perpendicular to the chord. It is sure, 100% sure. So my theorem 10.4 is proved. The line drawn through the center of the circle to bisect the chord. Okay, so the line drawn through the center of the circle is OM, and through the center of the circle to bisect the chord. To bisect the chords means it is already bisecting the chord, is now surely perpendicular because it is making an angle of 90 degrees over here. Okay, so my theorem is proved, hence proved. This thing is important to show that it is equal to 90 degrees. Students just leave over here showing the angles to be equal. But angles are equal, but it is not proving that they are 90 degrees or not. So we have to also do these steps also we have to also cover in order to prove that OM is perpendicular to the chord AB. Okay. So in this manner, we have to prove both the theorems. This theorem 10.4 is just the converse of theorem 10.3. Okay, so in this session we have proved theorem 10.3 and 10.4. In the later sections, we will be proving the rest of the theorems. So thank you. So please subscribe my channel and also share my videos. And if you have any doubt, you can ask me in the comment section. Thank you.